This video is about distances on lines of latitude. When a journey is made between two places that are on the same latitude, that is, travelling either east or west, the traveller will not always be travelling on a great circle. Trigonometry can be used to show that the radius of the Earth at latitude alpha is given by r cos alpha. This means that the formula for calculating the distance along a parallel of latitude is distance equals 2 pi r cos alpha times theta over 360. You don't really need to understand the complex geometry involved. All you need to understand is that the cos alpha factor that has appeared in the arc length formula takes care of the fact that the circle that we're travelling on is smaller than the 6,371 kilometres that we've used for the radius of the Earth. Let's take a look at some worked examples. Both the locations in this question are on the 20 degrees south line of latitude. One is 15 degrees east and the other 35 degrees west of the prime meridian. A plan view, that is a bird's eye view of the Earth as if you're in a spaceship looking down directly above the North Pole, is very useful in questions involving east-west travel. Here's the formula for east-west travel on a line of latitude. The angle theta is the angle subtended and it's shown in red on the diagram. In this case, it's found by adding the longitudes of the two locations, 15 degrees east plus 35 degrees west, a total of 50 degrees. Alpha is the latitude of the two locations, 20 degrees. After substituting, the distance is easily calculated. In the second worked example, both places are on the 50 degree north line of latitude, but one is 10 degrees east and the other 40 degrees east of the prime meridian. Our plan view shows the places and the angle subtended by the travel in red. In this case, the angle is found by subtracting the longitudes. 40 degrees minus 10 degrees equals 30 degrees. So we substitute theta equals 30 degrees and alpha, the latitude of travel 50 degrees, into the formula and solve. Notice that in this case the angular separation was found by subtracting the longitudes. In the previous example it was found by addition. You can find the angular separation theta using a plan view diagram as in the examples above, or you might like to apply the following rules. If both places are to the east of the prime meridian, then subtract the longitudes to find theta. If both places are to the west of the prime meridian, then subtract their longitudes to find theta. But if one location is to the east and one to the west, then you add the longitudes. But if your answer is greater than 180 degrees, you need to subtract it from 360 to find theta. Let's do some more examples together. This one is east-west travel on the 40 degree north line of longitude. We draw a plan view diagram. One place is 10 degrees west and the other 35 degrees east of the prime meridian. This is the formula used for east-west travel. In this case, theta is found by adding the longitudes. 10 degrees plus 35 degrees equals 45 degrees. Alpha is the latitude of travel, that's 40 degrees. You can do the arithmetic easily on your calculator. In the second example, both places are on the 25 degrees south line of latitude. We draw our plan view. Always draw this view above the North Pole, even though both these places are in the southern hemisphere. It could lead you into error otherwise. P is 17 degrees west and Q 58 degrees west of the prime meridian. The angle alpha is shown in red. This time we're going to find it by subtracting the two longitudes. 58 minus 17 equals 41 degrees. Alpha is the latitude of travel, that's 25 degrees. Substitute the information and use your calculator to find the distance involved. Now, it's time for you to do some practice of this technique.